Hello everyone. In today's video, we'll solve a 2012 previous year question from your prelims examination, and the topic is solar wind, or topic is related with solar wind and the Earth's magnetic field and magnetosphere. Now let's take a look at the question. So please pause the video and see if you can solve this question. Let's start the discussion with solar flares. Now another term for this is solar wind. Due to the various magnetic activities and magnetic interaction going on the surface of the sun, we'll be having outbursts of energy coming from the sun. Like these outbursts of energy will be traveling in all directions, and they are actually charged particles. Now in the previous video we have seen charged particles, they will be having positive or negative charge, and due to this high energetic event taking place on the surface of the sun, we'll be having charged particles coming from the sun, and they will be traveling in all directions. And if they reach the Earth's surface, it's very hazardous for life. And the Earth's magnetic field actually protects Earth from the solar wind or the solar flare. Earth is actually a magnet because of the Earth's interior. We are having solid iron core in the Earth's interior, and due to that, Earth is acting as a magnet, and it's having north magnetic pole as well as south magnetic pole. As you must have seen, as you must have studied earlier, if there something is a magnet, we'll be having field lines going from south to north magnetic pole, right? For Earth also, it's having these magnetic field, and this we call it as, that extension of that magnetic field, we call it as magnetosphere. Now the magnetosphere protects Earth from the incident solar wind or the solar flare or the charged particles coming from the sun. Okay, now let's see how they are doing that. As you can see in this picture, from sun we'll be having solar flare coming towards the Earth, and Earth's magnetic field diverts these charged particles towards its poles, right? Or you can imagine this as a flow of river, right? The river is flowing in one direction. Now imagine as an obstacle there's a pebble in the flow of this river. So what happens is that the water will flow on the sides of the river, sides of the pebble. Same way here, the Earth's magnetic sphere, you have to imagine it as a shield, you have to imagine it as a pebble, right? So when the solar wind is coming, right, these magnetic shield will divert the charged particles coming from sun, right? And these charged particles, because of the magnetic field, the way in which the Earth's magnetic field is aligned, these charged particles will be coming more towards the Earth's north pole as well as south pole. I'm not talking about Earth's geographical north pole or south pole, rather than Earth's magnetic north pole and south pole, right? Now this charged particle in the Earth's magnetic north pole and south pole, when they're reaching there, when the charged particles reach the atmospheric layer, what happens is that they will collide with the ions in the ionosphere, and that can create aurora formation, like an optical phenomenon, right, which we have seen in the previous video. So this is all regarding the solar wind, and you have to understand that this term is sometimes seen in news regarding climate change. There are certain climate change deniers, and the argument put forth by the climate change deniers is that the events like solar wind is resulting in global warming. It's not entirely due to human anthropogenic effect. Anyway, there is another term regarding the solar wind and solar flare. It's called as sunspot. For a detailed explanation on sunspot, you can refer to our channel, search sunspot new IAS. You shall get that video regarding sunspot. Anyway, it's almost same concept. Even during sunspot, we'll be having more solar wind or the charged particles coming from sun. Now the importance of this topic, because of, as I said earlier, due to climate change deniers, this topic is in news, and you can expect a prelims question on this. Now this is the aurora formation created in the high latitudes of northern hemisphere and southern hemisphere due to the charged particles from sun colliding with the ions in the ionosphere. Ions are also charged particles, but from the sun, these charged particles will be traveling with very high speed, and if they reach the Earth's surface, it will be very damaging for the life. It will be very difficult for life to survive on Earth. Now in this question, right, that electrically charged particles from space traveling at speeds of several hundred kilometers per second can severely harm living beings if they reach the surface of the Earth. What prevents them from reaching the surface of the Earth? Now this is an ABCD question with a D option, as none of the statements A, B, C given above is correct. So if you are having an ABCD question, you have to make sure before marking like in any of the statement, you have to read all 4 statements. Sometimes like the answer might seem like A option is correct, and while we are marking A, then only we will be seeing like the in D option, sometimes it will be like both A and B or both B and C. So make sure you read all the 4 statements before answering a 4 statement question. Now any 4 statement question, like you must be knowing like in like statement type of question, like with like options like 1 only, 1, 2, 3, 2 and 3. You will be sometimes able to do elimination method. Probably without knowing all the statements, you will be able to get into the answer. Now in this regard, the ABCD questions are actually difficult to answer because one of them is the correct answer. We cannot eliminate any of the statements, right? But that being said, most of the ABCD questions, like that can be 2 statements can be sometimes eliminated. How? In the sense, like there will be some absurd or illogical statements in among the options, right? I mean, with the base knowledge regarding the concept or the subject, you will be able to understand that even though the statement seems correct, it is actually illogical or absurd, right? So whenever you are solving these ABCD questions, always try to look for like these absurd and illogical statements first, and you have to eliminate that first, right? Then the chances or the probability of correcting by marking it correctly will increase. Again, here, like as you must have heard, I mean as you must have seen in this video, you'll understand that the answer here comes out as A, which is Earth's magnetic field diverts them towards poles, and that protects Earth from the incoming solar wind, or as it is said in this question, electrically charged particles coming from space. Okay, now let's see what are the illogical statements in this among this option, right? So like in second one, ozone layer around the Earth reflects them back to the outer space. Now if you have studied or if you got a base knowledge regarding ozone layer, we'll know that like an ozone layer protects us from UV radiation, right? So the second statement cannot be correct because like they cannot protect us from the charged particles coming from the space. Now third statement, moisture in the upper layers of the atmosphere prevents them from reaching the surface of the Earth. Again, if you have studied, like if you know basic things regarding the atmospheric layer, most of the dust particles and most of the larger amount of water vapor is concentrated in troposphere, right? As we go towards the higher layers like stratosphere, mesosphere or thermosphere, the amount of the water vapor will be very less. Larger amount of moisture is there in the troposphere. So if you know this base knowledge, the C option, like moisture in the upper layers of the atmosphere. So there are no moisture in the upper layers of the atmosphere, and you can eliminate the C statement, right? So you have to choose between A and D, and here answer comes out as A. The Earth's magnetic field diverts them towards its poles. Actually, this topic is very important. In 2018 prelims also, UPSC asked a question regarding the Earth's magnetic field, the way in which it changes its polarity, right?